Hey, so this is your linear programming packet. This is number 4. Let's give this a shot. So Shua is an amateur artist who specializes in geometric design. She is trying to get ready for an art fair next month. She paints both watercolors and pastels. Each type of picture takes about the same amount of time to paint. She has $180 to spend on supplies and time to paint at most 16 pictures before the fair. Materials for each pastel cost $5, and materials for each watercolor cost $15. Alright, so she's got this cost that she definitely has limiting her. Shua makes a profit on $40 for each pastel and $100 for each watercolor. How many of each type of painting should Shua make in order to maximize her profits? So we have two different types of paintings. So we want to know, we're done when we know how many of each type of painting she should paint. So, we could almost start answering the question, but then just fill in the blanks once you know it. So you should, let's go with this. 1, she should paint blank pastels and blank watercolors. We unfortunately don't know how many of each. We're supposed to find that out. So let's make X be our unknown, our number of pastels. Let's make Y be our unknown, our number of watercolors. So X represents the number of pastels, Y represents the number of watercolors. So let's go back through. She paints both watercolors and pastels. Each type of picture takes the same amount of time. Now let's talk about money. She has $180 to spend. So that's a limiter. And she has time to spend painting 16 total pictures. There's another limiter. Materials for each pastel cost $5. Materials for each pastel cost $5. Materials for each watercolor cost $15. She makes a profit of $40 on each pastel and $100 on each watercolor. So I'm just going to I'm highlighting in yellow the watercolor information. I'm highlighting in green the pastel information. So now let's try to build some inequality equations that define our constraints. So one constraint is, first of all, that she can only make 16 pictures. She has time to make 16 pictures. X is the number of watercolors. X is the number of pastels, Y is the number of watercolors. When you add up the total number X and Y, it has to be less than or equal to 16. So when we take X plus Y, X is the number of pastels, Y is the number of watercolors. When I add them together, it has to be less than or equal to 16. That's 16 paintings or fewer. Then there's the money limiter. So how much does each pastel cost? Each pastel costs $5. So 5 times X, 5 times the number of each pastel painting she makes, it's going to cost her $5. If she makes 10 pastels, it costs her $50. Then each watercolor painting costs $15. So she'll have to take 15 times Y, Y being the number of watercolor paintings. If she paints 10 watercolor paintings, it's going to cost her 15 times 10, $150. When we combine the costs of the two different types of materials, we have to stay under our budget of $180. Lastly, so these are our two constraints, folks, by the way. But then there's opportunity to make money here. So these are our constraints. We'll graph these in a second, but then in the end, we want to make a profit. So the profit equation, we might as well go ahead and write, but we're not going to graph this. We just plug in our vertices or corners into that. She makes $40 on each pastel, so $40 times each pastel plus $100 on each watercolor. So 100Y. And that equals the profit. Alrighty, so let's graph these two equations. They suggest using a scaling of 2. So here's 4, 8, 12, 16. 4, 8, 12, 16. I'll go up from, I guess I should need to go up farther on the Y, I think, to graph this correctly. All right. So this equation right here, you could subtract x. I'll write that over here. X plus y is less than or equal to 16. You could just get the x-intercept, that'd be 16, and the y-intercept would be 16 by plugging in 0 for the other value to get the intercept. But otherwise, you could subtract x and you get y is less than or equal to negative x plus 16. So your y-intercept is 16. You go down one, right one, boom, you get your line. That's a solid line, and we have to shade below it. Because when I'm shading below, that's giving all the different combinations, x's and y's, of pastels and watercolor paintings. And anywhere on the line would be a perfect combination of 16. Then there's the cost factor. So we have 5x plus 15y is less than or equal to 180. So we'll subtract 5x and subtract 5x. So we get 15y is less than or equal to negative 5x plus 180. Divide by 15. Divide by 15. Divide by 15. Y is less than or equal to negative 1/3 x plus 12. So to graph this line, should have done it in a different color. I'm going to do this one in blue. We're going to start at the y-intercept of 12 and then go down 1, right 3. And because I need to shade below this line, folks, I actually don't even need to keep the line going. I'm going to zing it, and then I've got to shade below it. So this region, I'll just re-highlight it, is my feasible region. It meets both constraints of time and of money. So from here, we're going to check our feasible region. By the way, folks, I'm just looking at A and B. We've done that right there, and the cost, and we graphed using a scale of 2. And so our feasible region, our vertices of it are 0, 12, and 6, 10, and 16, 0. So we had 0, 12, 6, 10, and 16, 0. And we made, so now we checked those in our profit equation, the 40x plus 100y. Profit equals 40x plus 100y. So now let's check them. So here, no money on pastels, but do 12 watercolors, so we get $1,200. 40 times 6 plus 100 times 10 is going to be 1,000 plus 240 is 1,240. And last but not least, 16 times 40. Oh boy, plus 100 times 0. Well, 15 times 40 is going to be 600. So that's another 40. So I think that's going to be 640. 640. Yeah, that's 16 times 4 is 64. Add a 0. We're good. So our maximum profit is going to be right here. Whoa, that's not how you spell max, but that was creative. What gives you the maximum profit is going to be 6. I forgot what X was now. 6 was pastels, yeah. So, whoa. 6 pastels and 10 watercolors. All right.